Alright, this is Mr. Gillum, and today we're going to connect our algebra reasoning with our geometry reasoning. And so we're going to talk about proofs a little bit. Now you may have done some proofs with equations in algebra before. We're going to save those for tomorrow. We're going to do a little review on those. But for today, we're going to be talking about postulates and just a very informal proof. It's kind of like the whiteboard warm-up almost, as far as what we're going to do today. An explanation of what we're doing. A postulate, also known as an axiom, is basically something we're supposed to accept as being true without really having any proof. All right, and so I've got a list of postulates that are accepted to be true, and we're going to talk about a few of them. The first one here says that the line N is the only line through points P and R. So there is no other line that I can draw, and it might seem like common sense, but it's a postulate. There's no other line that I can draw through P and R that's actually a line that's it has to be a straight line. It can't be like a quadratic or a parabola or anything. This does not count. Okay. Between 2 points, there's only one line. Okay, there's not more than one line. It's just one line. That's it. That's the only thing. That's the only way you can do that line is straight through both those points. Postulates about points, lines, and planes. Okay, let's talk about some more. Any three non-collinear points, there is one plane. All right, so it doesn't matter where the points are as long as they are not collinear, meaning they're not on the same line, you can draw one plane through them. All right, so for example, plane K is the only plane through non-collinear points A, B, and C. Okay, A, B, and C are not on the same line, but plane K goes through A, B, and C. Okay, that one's actually kind of a tricky one. There, you might want to look at that one again. A line contains at least 2 points. Line N contains points P, Q, and R, which is at least 2. When it says at least 2, that means 2 or more. So it takes at least two points to have a line, but there's technically infinitely many points on this specific line. Take a look at this next part here. A plane contains 3 points not on the same line. So plane K contains non-collinear points L, B, C, and E. Okay, so this one is actually kind of similar to this guy. A little different, but kind of similar. It takes 3 points that are non-collinear, and you could put a plane through them. And this guy says a plane contains 3 points not on the same line. So very similar. A plane contains many different points. Infinitely many. They might not all be labeled, but they're all there. If 2 points lie in a plane, then the entire line containing those 2 points lies in that plane as well. So if you have those 2 points, A and B, that line goes through, and we are using that line to determine our plane K, and we know the line is in K, then all the points on that line are also on K. So any of these points, if I put more points on here, would also be on K as well, on plane K. If 2 lines intersect, their intersection is exactly 1 point. Okay, it's not going to intersect twice. The lines can only intersect once or no times. There's no other way around it. They're not going to curve back around somehow and cross another place or anything like that. Lines are, that's part of the definition of a line, is it's straight and it's continuous and it's never ending. And so where they intersect is just a point. And similarly with lines, planes, when they intersect, that's actually just a line. So this diagram is much better than anything I could have drawn, so I went ahead and stole that from the internet. Where those two planes cross, there's actually a line there. There's a line of the intersection. We would call this one line W. All right, paragraph proofs. There's the fun part. A proof is basically a logical argument that uses deductive reasoning to move from a hypothesis to a conclusion. So basically, you believe something to be true. You think it's true. That's your hypothesis. And then you have to use definitions and postulates and theories and laws and theorems or whatever. You have to prove that it is actually true and come up with a conclusion. So a theorem is a conjecture that has been proven. So we went from postulate, where there's really no proof, but we accept it to be true, to a theorem, which it is proven. It's a true thing. Okay. So we had this nice big long proof, and it looks nasty and long, but it's really not as bad as it seems. It says, given that C is between A and B and AC equals CB, write a proof to show that C is the midpoint of AB. So let's just draw a little diagram here, and maybe that'll help us. We have A and B. And it says that AC, segment AC, so let's put AC on here, is congruent to CB. So these sides are both equal. So now we need to prove that C must be the midpoint of AB. Now it might seem like common sense, but there's a process we need to really go through here. All right. So what I want to do is I want to really emphasize the word definition. Okay, there's some definitions here. I see the word definition in this proof several times, and that's basically where we're going to be right now. Okay, it might seem elementary, but we're going to start with those words definition to help us prove that C is the midpoint of A and B. Okay, now all it says is C is between A and B, and it also says these segments are equal. It doesn't actually say C is the midpoint, so that's what we're going to get at. So what we're going to do is this. I'm going to say if C is between A and B, then by the definition of between, A, B, and C are collinear. All right, they are collinear. We know they all have to be on the same line. And segment AC plus segment CB has to equal AB. All right, so if C is somewhere in between, that means that this segment plus this segment must be equal AB, the total length. All right, so that's our first part. We know that C is halfway in between, or we don't know halfway between, but we know that C is in between A and B. So we're going to start with that definition, just what between means. And between means it's collinear. So if AC is congruent to AB, then by the definition of congruent, AC equals CB. So congruent just means equal. All right, that's all that sentence says. Let's not make it too complicated. That's what congruent means. It means each side from C to B and from A to C, those are both equal. So I need to put that in my proof because that's something that needs to be interpreted. And then finally, what a midpoint actually is, from the definition of a midpoint, C must be the midpoint of A and B if both sides are equal. Okay, and a midpoint basically says that it is halfway in between A and B, which we know to be true because AC is equal to CB and they are all collinear. Therefore, C must be the midpoint of AB. All right, we call this an informal proof right here. It's just a paragraph, an explanation. You want to use the word definition because we don't have a lot of theories or theorems under our belt yet, and a lot of postulates that we're going to be using. And so it'll be a little open-ended for you, but it's just one of those things you have to be really, really descriptive on. And we're going to practice a few of these, but we're going to get into the more concrete proofs so that you actually know for sure that you are getting the correct definitions and things like that on your paper. It'll be a little less vague. If M is the midpoint of AB, then AM equals or is congruent to MB. So that's your midpoint theorem, and that's just how we proved it right there. We knew that between meant it had to be collinear. We know that congruent means equal on both parts. If AM equals MB, then therefore M must be exactly halfway in between A and B. That's basically what that huge paragraph said, and it's the midpoint theorem. So that's it. That's all for today. So I introduced you to proofs, and we're going to practice a little bit in class, and there will be more to come later. So hopefully you understand that this guy is a paragraph proof, and you've been introduced to some of the postulates that you may or may not have been familiar with before.